Okay, so your Unit 8 review for Unit 8 test is here. We have a parent function of 2 to the x, and the question is what was transformed to get 2 to the x minus 4 plus 3. Okay, now remember, if it's up here, it's horizontal and it's a lie. If it's out here, this is vertical, no lie. Okay, so when I see minus 4, I really think that's, since it's a lie, it's really a plus 4. So that means it's going horizontally to the right 4. Cool. And then this is vertical, no lie, so plus 3 is up 3. So off to the right here, this is the parent function. Okay. Can I take that and move all those points right 4 up 3? 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. It had an asymptote right here, but now it's going to move up 3. Cool. So that was letter B. I sketched a graph. I moved each point right 4 up 3, and my new asymptote moved up 3. So when they're asking for the asymptote, remember a horizontal line goes through the y-axis at 3, so it's y equals 3. Cool. Now for domain, remember it goes forever to the left and forever to the right. That is all real numbers, and for exponential, it's always all real numbers for domain, but the range is y, and it is only above this dashed line going through 3. So above is not equal because it's dashed. Above is greater than, not equal, not underlined, 3. Okay? So the asymptote is at equals 3. The range is above it, so it's greater than 3. Cool. Okay, so we have the same graph, 2 to the x, the f of x, this first one, and then g of x has been transformed. What is the equation? Okay, so what happened? From here, it looks like it went down to here, and then here, it went down to here. So it did a shift down, how much? 1, 2, 3, 4. So if the shift is down 4, then I know g of x is going to be f of x minus 4. It's not on the inside of the parentheses because it's not horizontal, but it's vertical, so it's out here. So really, g of x equals the parent function 2 to the x, and then the minus 4 is going to be a big normal minus 4 right here, not in the exponent because it's not horizontal, it's vertical. Okay. So that's how vertical transformations work. It's a regular number, not in the exponent, and it's not a lie for vertical. Cool. All right, it's all for x. Now, step 1, are the bases the same? 5 and 5 are matching, so you can slash those out and set this equals this. So 2x plus 1 equals x plus 9. And then you could solve that. Like you might be able to end solve it, but to get rid of this, when we have x on both sides, we want to get rid of the smaller x, which is this 1x. So the opposite of 1x, positive, is minus 1x. And I'm left with just x plus 1 equals 9. And then to get rid of that plus 1, I subtract 1. X equals 8. Cool. Now on this one, 2 to the 3x plus 8. 16 to the x minus 4. These bases don't match, okay? But what do I know about 16? Well, I know 16 is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 16 is 2 to the power of 4, because 2 times 2 times 2 times 2 is 16. So this 16 is going to become 2 to the 4. And then that's to the power of x minus 4. This left side, I'm just going to bring it down. Okay. So now I got the same base. The one thing I notice is that I have a power to another power, so I have to distribute this. So these bases are going to cancel out. I have 3x plus 8 equals 4 times x is 4x. 4 times negative 4 is negative 16. Cool. And once again, I'm going to get rid of the smaller x, which is 3x. It's positive, so I'm going to subtract 3x. Subtract 3x. I get 8 equals 4 minus 3 is 1x. And then my last step to get rid of the lower minus 16 on the side of x is to add 16. 8 plus 16 is 24. Okay. So number 5. Okay, on number 5, I don't want to have these two numbers here, so I want to get rid of this 5 out front. So I can divide by 5. So 2 x plus 4 equals 32. 160 divided by 5 is 32. Now, off to the side here, what does 32 equal? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So 32 really equals 2 to the power of 1, 2, 3, 4, 5. Alright, so this 32 is going to turn into 2 to the 5 power. This is going to stay the same because it's already got that 2 base. And now, do you see how both bases are 2? Now we can cross them out and write x plus 4 equals 5. We got one step left to get rid of that plus 4. We subtract 4. 5 minus 4 gives me 1. Cool. So that is the front side of your review. Let's go to the back side. All right. So you get your formulas up top. So remember, this first one is growth. The second one is when you have a half-life or doubling or whatever. Okay. And then this one over here is continuous, P-E to the RT. Okay. So the population of Slackersville can be modeled by this. Okay, we already have the model. T is the number of years since 2000. What was the population in 2000? Okay. So if this is years since 2000, that's the beginning. And what was the population at 2000? That's going to be your starting amount right here. Okay. It's going to be your initial value. So you get 255. Again, because they're giving you the year that it starts. Okay. That's what that first number is going to be, the P, the principal. Okay. Is the population increasing or decreasing? So this number right here, Okay, 0.85 is less than 1, so that's going to be decreasing. It's going down. By what percentage did the population increase or decrease each year? Okay, so it's not 85%. It's not 0.85, okay? You have to take 100. So first of all, 0.85, you got to move it 2 to the left, 2 to the right to make it 85%. And then what you do is you take that away from 100%. That's how much it went down. And the answer is 15%. All right, you purchase a car for $16,500. The car depreciates in value every year. So this is not continuous. It's just every year. So we're going to use this formula. Okay. Now, this is the same thing. Like this is your P. Okay. To write an equation that models the situation. Okay. So what does my P equal? What's my initial value? 16,500. What is my R value? My rate? It says 9.75%. Remember, I want to move the decimal 2 to the left and get rid of the percentage sign, so it's 0.0975. That's my rate. And then my T, my time, that's what's missing. Okay, so we're going to write this in. Y equals P 16,500 parentheses 1. Now, is it adding or subtracting? Depreciate means minus or negative, okay? So 1 minus 0.0975 to the power of t. Cool? So what's the value in 10 years? So if t equals 10, then I'm going to plug it into that formula. 16,500, 1 minus 0.0975 to the power of 10 this time. So let's go ahead and type this thing in to a new calculator. 16,500 parentheses 1 minus 0.0975 caret and then 10 years. We end up getting $5,915.02. $5,915.02. All right. It says a scientist has 400 grams of a certain isotope. The half-life of this isotope is 20 hours. Formulate an equation that models the amount of carbon remaining after T hours. So remember, half-life has the half in it. Okay. So we're going to use this formula, y equals p to the 1/2 t over k. Y equals p parentheses 1/2 to the power of t over k. All right, so let's figure out what our P is. The principal, the initial amount, is 400. And then our T is our time. We don't know that yet. But our K, our period that it takes to make it half, is 20 hours. So our equation is going to be y equals 400 times 1/2 to the t over 20. Okay, so now we just need to figure out the amount of time. Okay, if it gave us an amount of time to figure out, then we can plug it into t. But for now, that's it. That's our equation. Analyze the table and use the regression to write an equation that models the data. Okay, now this whole unit 9 is on exponential, right? And the one we learned recently is exponential regression. So remember, we go to spreadsheets, lists and spreadsheets, which is number 4 when you do a new document, and then you type in X and Y at the top, and don't at the very end you're doing menu 41A. So let's see what it looks like. Press on your document, don't save. Number 4, X and Y must go at the very top. And down here, I can type in all these numbers. Okay, and then I press menu 41A, X on X, Y on Y, and then I hit OK. And that gives me an A and a B value. So A is 3, B is 3. So my equation is going to be 3 times 3 to the power of X. A times B to the power of X is the exponential function. Okay. Alright. Last one. 10. Describe a real-world situation that can be modeled by the equation y equals 10 times 2 to the x. Okay, describing a real-world situation. I start with 10 candies. That's your starting amount right there. And what does 2 do? And they double, times 2 each day. It could be 10 of anything doubling, and that's a real world situation, and that's good.